Hi Science 10, welcome to 2.4, all about water. We know how important water is to our body and to our health, as we are a majority of water, and so are most living things. Unique qualities about water is that all three states are found on Earth. The frozen version is less dense than the liquid version, and that's not the case for pretty much any other substance. If you have a frozen version of another substance, it will sink in that liquid. And for example, if you freeze some oil and you put a cube of oil in liquid oil, that cube of oil will sink. Water, back to water, has a high surface tension, and you have a chance to watch a video of insects that can walk on water to make you remember about that. And the boiling point and melting point is higher as well. Water has a high surface tension, high adhesion and cohesion. And looking at the next slide, we'll talk about cohesion, and that's when the molecules are attracted to each other. And we'll look at the molecular reason for that in a second here. And adhesion is when molecules of water are attracted to molecules of other substances. So in cohesion, if you can think of these water molecules attracted to each other, that is why water forms droplets very easily. And adhesion is why you can pour water out of a glass and give it another shake and a couple of droplets come out, because water was sticking to that other chemical that's glass or even plastic. Okay, the molecular structure of water can explain those characteristics. First of all, water has a shape that's not like linear. It is where the hydrogens are actually off to the side of the oxygen molecule, of the oxygen, and you'll see that when you have the hydrogens off to one side, that makes that side more positive because they have lost their electron to oxygen, and oxygen makes this side more negative because it's grabbing those electrons. So this is called a polar molecule when it's got charges that are different on each side, but it's also why water easily attracts positive things over this side and other negative things on this side. So it's very easily dissolving many other substances, no matter what their charge is. Water has a way of dissolving it and attracting it. You can take a peek at the Amoeba Sisters video. Lots of fun. Okay, so when you end up looking at this positive side where the hydrogens are on a water molecule, you can see that that would be where it would attract the negative side of a neighboring water molecule, and the bond that forms when the positive side here attracts the negative side of a neighboring water molecule, that's a hydrogen bond. And hydrogen bonds are like pretty strong bonds that will make a whole bunch of water stick to each other and form that droplet and form that cohesion. So here we have the one water molecule attached to another one where the oxygen is attached to nearby hydrogen. So this is called an intermolecular bond, which is bonds between one water and another water. And then we'll look at the melting point and boiling point. You know that it's high when you have to wait for water to boil by adding a lot of heat to that pot of water. And you need to add that energy in order to break those intermolecular bonds, because the hydrogen bonds are strong. And so it takes a lot of energy to break them. The high heat capacity results when you can add a lot of heat before that water changes state. So again, that is due to the hydrogen bonding as well. So it takes a lot of heat before liquid water will evaporate and turn into gas. It takes a lot of heat to take a frozen chunk of ice and break those bonds and melt it into liquid. Water also has a concave meniscus, and that would be because of the attraction of that water. It doesn't lay flat in a test tube, for example, or a beaker. It gets attracted to the, let's say, glass or plastic, especially glass, and along the edges. And so it will have that caving in surface. And you can see a real photo of it right here. And if you look at other substances like the liquid metal mercury, it does not have that same adhesion. It will actually have a convex meniscus, but because of adhesion, water has this concave meniscus. If we were to measure, just an aside here, fun fact, if you were to measure how much water this tube has, we always measure at the bottom of the meniscus. So we're not measuring basically air in part of it. So we always take a measurement that would be right here, if you ever had to do that. Water, as we mentioned, when it's frozen, will float in the liquid. And it's because when it freezes, the molecular structure in there is less dense, so it freezes in a structure that kind of opens up air spaces inside, and it will then float. The high surface tension is also because of that sort of hydrogen bonding and cohesive structure. And here's some examples of a water boatman and a lizard walking on water. Take a peek at this video. Very fun to see that. Okay, yeah, so thanks for joining me for 2.4. That wraps up chapter 2. Bye for now.